There is a bizarre thing preserved in the fossil record that honestly we are still trying to figure out what it means. And that's the presence of feathers. Yeah, those things that cover birds and some dinosaurs. They're made of keratin, like our hair and nails, and they're basically the defining characteristic of birds today. But because they're made of keratin, they don't preserve well in the fossil record. Sure, you might get an impression of a feather here or there in amber, or in a rare case have a whole one preserved in a fossil, but we shouldn't expect to find many feathers just lying around in the fossil record. So then why do we find them so often? If feathers are so poorly preserved, the answer lies in knowing where to look. In 1861, the first Archaeopteryx was discovered in Germany, a creature that was literally the Rosetta Stone for understanding bird evolution. This first Archaeopteryx specimen had impressions of feathers preserved on its wings and tail, which helped to link birds and dinosaurs in a way that nothing else could. Unfortunately, this specimen is now badly damaged. The original preparator sliced off all of the rock matrix surrounding the fossil, which removed most of the details. But other specimens would come along that had feathers preserved with exquisite detail, like the famous Berlin specimen. A few years after the first Archaeopteryx was found, another weird theropod would be discovered in China with even more impressive feathers. Meet Microraptor, one of my favorite dinosaurs of all time. These little dinosaurs lived during the Jurassic period in what is now China, about 160 million years ago. The name raptor comes from the fact that it had large claws on the ends of its fingers, perfect for catching prey. The genus includes 4 species, but only Microraptor guy has been found with feathers. Interestingly, Guy was found with 2 different color patterns. One was mostly black with white patches on the wings and tail, while the other had reddish-brown feathers on its head, neck, and chest. The black and white one is notable because it's one of the best candidates for countershading we know of in dinosaurs. Countershading is an adaptation where the top of an animal's body is darker while the bottom is lighter. This helps the animal blend into the sky when viewed from below by predators and above by prey. Some modern animals with countershading include sharks, some fish, various reptiles, birds, and even mammals like squirrels and giraffes. Countershading is thought to have first evolved in aquatic animals as a way to camouflage themselves against the dim light coming from the surface. The idea is that if you can match the ambient light around you, you become less visible, and therefore more likely to ambush your prey or avoid being seen by a predator yourself. If you want to learn more about countershading, I did an entire video on the subject not too long ago. I'll leave a link in the description. Now back to the strangely feathered dinosaurs. Another really well-preserved theropod from China is Sinosauropteryx. The type species, Sinosauropteryx prima, was described in 1996 based on a single specimen. Like Microraptor, this dinosaur also lived during the Jurassic period, but this one was found slightly further south, closer to the coast. Unlike Microraptor, Sinosauropteryx is known from several specimens. What makes it interesting, though, is that it's one of the earliest dinosaurs we know of with feathers. It seems like the feathered dinosaurs were mostly limited to the eastern side of the supercontinent Pangaea. As you can see on this map, the known locations of these dinosaurs get pretty close to the coast. Maybe they needed the ocean nearby to survive. We don't know for sure. What we do know is that Sinosauropteryx was covered in down feathers, the same kind that modern birds have. Down feathers are soft and fluffy and function to keep the bird warm. Birds today use contour feathers to shape their bodies and provide streamlining during flight. Down feathers are great for insulation, but not so much for show. In 2007, a relative of Ankylosaurus in the genus Boreopelta, Mark Michelli, was discovered in Canada. Like Sinosauropteryx, this dinosaur also had downy feathers. Unlike Sinosauropteryx, this dinosaur was huge, growing to about 6 meters long. The discovery of feathers on this massive herbivore was completely unexpected. After all, ankylosaurs look nothing like birds. It turns out that not only was Boreopelta Mark Mitchell covered in down feathers, it also had long feathers extending down its tail, forming a kind of plume. These tail feathers may have been used for display. Today, males often have longer, larger feathers than females to attract mates. So it's possible that the ancestors of ankylosaurs were brightly colored, feathered dinosaurs that lived in groups. The males would have displayed their fancy tail feathers to attract mates. Over millions of years, the females would have chosen the most colorful and extravagant plumes until eventually the ancestors of Ankylosaurus evolved from these proto-birds. Okay, so we've talked about a few dinosaurs that are closely related to birds, but what about the birds themselves? It turns out that fossilized feathers can help us understand how birds evolved. Their closest relatives, the theropod dinosaurs. One such bird is Confucius ornis. Confucius ornis is known from many specimens preserving both body and wing feathers. Interestingly, Confucius ornis lived alongside feathered dinosaurs like Archaeopteryx. In fact, fossils of Confucius ornis and Archaeopteryx were found in the same rock layer in China. The presence of these two groups of organisms together gives us a better understanding of how birds and dinosaurs were related. A study published in 2021 used scanning electron microscopy to image fossilized feathers of Confucius ornis. This revealed the structure of individual barbules in the feathers. Barbs and barbules are small, thin structures that come together to form the feather. The arrangement of these barbules is similar to that seen in modern birds. Knowing this helps us to understand how feathers evolved. The researchers concluded that feathers probably started out as scales on early dinosaurs, then gradually evolved into more complex structures as natural selection took hold. What's really cool about studying fossilized feathers like these is that they can tell us about the mummified animal without destroying it. Today, scientists can analyze the chemical makeup of a fossil to determine a number of things, including diet and sex. In 2019, researchers analyzed the feathers of a juvenile Archaeopteryx. They found that the isotope ratios differed between the body feathers and the tail feathers. This suggests that the animal ate a different diet than we previously assumed. The juvenile Archaeopteryx seems to have mostly eaten meat, unlike the adult Archaeopteryx, which mainly ate plants. Another study from 2019 used synchrotron X-ray technology to scan a fossil of Archaeopteryx. This allowed the researcher to identify the chemical signatures of iron and sulfur preserved in the feathers. These elements are often associated with melanin, the pigment that gives skin and feathers their color. The researchers identified at least 2 different types of melanin preserved in the feathers, meaning that this Archaeopteryx was probably brown or black. In 2023, the oldest bird nest ever found was discovered in China. The nest contains multiple eggs, but one egg has an embryo inside. Researchers used X-rays to scan the interior of the egg without cracking it open. This revealed the preserved feathers of the embryo. These feathers are different from the down feathers we've seen before. They are long and pointed, much like the contour feathers seen on modern birds. This suggests that the evolution of feathers was likely driven by the need for thermoregulation and display, rather than just flight. Indeed, the ancestors of birds probably didn't evolve feathers so they could fly. Instead, they probably evolved feathers to stay warm and attract mates. Flight came later when the birds adapted their feathers into wings. One of the coolest things about studying ancient ecosystems is that it allows us to compare past environments to modern ones. For example, studying fossils from the La Brea tar pits in Los Angeles has taught us a lot about the ecology of the Ice Age. Likewise, studying dinosaurs from the genus Maiasaura in Wyoming has taught us a lot about the late Cretaceous ecosystem. Maiasaura is an ornithopod, a group of mostly herbivorous dinosaurs that lived during the Cretaceous period. Fossils of Maiasaura have been found in rocks dating back 75 million years. In 2022, scientists discovered that Maiasaura grew up to 15 times faster than modern birds. Maiasaura lived alongside Ankylosaurus, Triceratops, and Tyrannosaurus rex. These dinosaurs were white, according to a study done in 2020. Scientists examined 2 fossilized specimens preserved in Wyoming. Using a technique called mass spectrometry, the researchers identified the presence of the protein osteocalcin in the bones of Maiasaura. Osteocalcin is only produced by living things that are warm-blooded. This suggests that Maiasaura were endotherms, much like modern birds and mammals. The analysis also revealed the isotopic signature of carbon and nitrogen in the tissue. The ratio of nitrogen isotopes can reveal the metabolic rate of an organism. The carbon isotopes can reveal the temperature at which the organism's body works. Together, this data suggests that Maiasaura grew up fast, like modern birds do. This supports the theory that dinosaurs and birds are more closely related than we once thought. As always, I hope you learned something new. Stay tuned for more. I'm the host. See you next time.